Hello, this is Logical, and today I would like to talk about the vastness of the universe. As I'm interested in astronomy, it has occurred to me that most people are unaware of just how far apart things are from each other. One of the main factors for this is all the heavily disproportionate images there are. Many times I have stumbled upon pictures of the solar system where the planets look really close to each other, or where Jupiter seems just twice the size of the Earth, which is very wrong. Another huge factor is that we weren't developed to understand such numbers. We can't possibly picture the distance of a light minute, for example. We were only made to picture a few kilometers or so. So, to make you understand the real scale, I'll have to cheat my way around those two factors. Thankfully, there happens to be a scale model of the solar system right in the city where I live. It's in scale 1 to 2 billions, so it's quite a bit smaller than the real solar system. At this scale, the Sun would be approximately 70 centimeters. So, this scale model is called the spacewalk, and the planets are at real distances compared to the Sun scale and that. So, just 30 meters away, we have Mercury. So, it's that little dot that is Mercury. It's just 2.4 millimeters in diameter. It's tiny, and it's 30 meters from the Sun, which was 70 centimeters. So if we keep this walk for 22 meters, we will hit Venus, the second nearest planet to the Sun, and we can see it down the road here. So Venus is clearly a bit bigger than Mercury, but it's still quite small compared to the Sun. It's still just a dot. So now we're heading for the third planet in our solar system, and you all know which that is. So here we arrive at the third. So it's 6 millimeters in diameter in this scale, and now we are 75 meters away from the Sun. So I want to ask you something. If this is Earth, where would you put the moon? NASA is aiming to get to Mars in about 2 decades. They aim for 2035, though Elon Musk and SpaceX thinks that we can do it already in the 20s. Here we reach Mars, which is at 140 meters from the Sun. These are the 4 stone planets in our solar system, but next is Jupiter, which is a gas giant, and it's a bit further away. You know, between these it has been 20 to 30 meters between the planets, but to get to Jupiter we need to go another 270 meters. So after a couple of hundred meters of the slope, we finally arrived at Jupiter, and this is the first planet where you actually can see the sphere from a distance, because, you know, the small planets, they are so small. Well, Earth is quite big, but on the scale they are small. But Jupiter is so big that it is even big in the scale. As you probably know, Jupiter is the largest of all our planets. So this is the largest we ever see. It's maybe 7 centimeters in diameter, so that's 1/10 of the diameter of the Sun. And
The sun will be somewhere down here, but you can't see it because trees. So something interesting, just a thought that occurred to me, is that at the scale of 1 to 2 billion, the light would actually go much slower than the rate we are walking at now. You know, the light takes about 8 minutes between the sun and the earth, but in this model we could absolutely walk to earth in just 1 minute. So it's quite weird. It's so much smaller than you think with 1 to 2 billion. It's weird. So, at 713 meters from the sun, we find Saturn, and even including the rings. Quite beautiful. A bit smaller than Jupiter, but still much larger than the stone planets. So Saturn is like Jupiter, a gas giant, but the rings are actually not made up of gas, but rather small stones. We have now arrived at Uranus, and well, it's clearly smaller than Jupiter and Saturn, but it still counts as a gas giant. At this scale it is 2.6 centimeters in diameter, and we are now at a distance of 1.5 kilometers from the sun. So our next stop is the 8th planet, Neptune. And Uranus and Neptune are the furthest apart of all the planets, so this will be the longest walk we make today. Okay, so this little fellow is 2 millimeters less in diameter than Uranus, but looks kind of the same, and we are now at 2.2 kilometers from the sun. So, at 3 kilometers from the sun, we finally arrive at... Oh wait, that's right. Pluto doesn't count as one of the planets, and therefore it shouldn't be in the scale model. It isn't actually removed, but it was vandalized. If it was still here, it would be a little smaller than Earth. Maybe like this. When walking this spacewalk, you really realize how small everything is and how huge the distances are. If we were to move beyond Pluto, where would we find the next things? Well, Voyager 1, the probe furthest away we have ever sent, it would be another 7 kilometers down the road. That's the furthest we have ever gone with anything. But beyond that, how much further would you go in that direction to find the closest star? What if we were to push the boundaries even further? What about how big would the Milky Way be on this scale? Please leave your answers in the comments, and I will upload another video with the answer.